Targeting tax objective number 3. The student will demonstrate an understanding of linear functions. In problem number 1, we are asked what are the coordinates of the x and y intercepts of 3y equal to 7 minus 4x. In order to answer this question, we need to put our equation in slope-intercept form. To do that, we begin by rewriting our equation. 3y equals 7 minus 4x. To get to slope-intercept form, we need to solve for y, so we will divide each term by 3. Reducing gives me y equals 7/3 minus 4/3 x. Remember, the coefficient of the x term is your slope, so our slope is negative 4/3. The 7/3 is going to be our y-intercept. So our y-intercept is 0 7/3. That is only half our answer, so we should not make a choice yet. We need to go and find the x-intercept. To do that, we need to get our graphing calculator out and graph this line. To graph the line, we need to go to our y equals and input our equation. So we have parentheses 7 divided by 3, close parentheses, minus parentheses 4 divided by 3, parentheses x. Zoom 6. Now we have already found our y-intercept to be 0 7/3. We need to locate this point, the x-intercept. We're going to use the calculate menu, which is above the trace. So second, calculate. On a TI-83 it is called the 0. On a TI-82 it is called the root. Both mean the same thing. So we'll go down to number 2, hit enter. It asks for a left bound. So we need to get our cursor to the left of the intercept we're looking for and hit enter. And looking for a right bound, we need to get to the right of the intercept. So move your cursor to the right side of the intercept, hit enter. For a guess, move your cursor where you think the intercept should be, hit enter. Our calculator has located the intercept at 1.750. When you look at your answer choices, none of them are in decimal form, so we need to use our calculator to convert this decimal to a fraction. So second, quit and go to your home screen. Type in 1.75, go to math. The first one converts to a fraction. Hit enter. You should have this on your home screen. 1.75 convert to a fraction. Now hit enter and we get the fraction 7/4. Now we know that our x-intercept is going to be 7/4. 0. Be very careful in checking your answers. The correct answer for this problem is B. But the other answer choices each are very close to what we're looking for. That is why it was important that we found both the y and x-intercept before selecting our answer. Problem number 2. Which equation represents the graph of the line below? We have worked problems like this before by using a linear regression. Before we do that, we must select 2 points that lie on the line. The first point that we will select is the point 0, negative 4. Another point that we will select is the point 3, negative 5. Now we will input these into our calculator and do a linear regression. We go to our stat key, edit. If you have something in your list, remember, go up to your list, clear, arrow down, go over, up, clear, arrow down. Remember, list 1 contains our x values, so 0, 3, arrow to the right, will contain our y values, negative 4 and negative 5. We'll go back to stat and over to calculate. We're doing a linear regression because we have a line. So number 4, enter. Notice the r value is negative 1. That is because we have a good linear relationship with a negative slope. Now it's time to write our equation. Notice that the a value is negative 0.33333333, repeating. Most of you will recognize this as negative 1/3. If you do not know the fractional value for this, remember, you can always go to your home screen, input, and change it to a fraction. Alright, let's write our equation. This would be y equals negative 1/3 x minus 4. Notice that all of the answer choices are in standard form. To transform our equation to standard form, we're going to multiply through and get rid of our fraction. So the first thing we're going to do is multiply each term by 3. That's going to give me 3y equals negative 1x, or negative x, minus 12. Standard form has a positive x value, so we want to move our x, negative x, to the left side. So our equation will become x plus 3y equals negative 12. Now we have our equation in standard form. Go and select the one that matches your equation. In this case, the correct answer is G. Problem number 3 tells us we are given the graph below. If the slope is multiplied by negative 1 and the y-intercept is increased by 5 units, which linear equation would represent the new equation? We're going to begin like we always do when looking for an equation. We're going to select 2 points on the line. The first point we will select is 0, 1. The second point is negative 3, 3. We will now do a linear regression to get the equation of the given line. Go to Stat, Enter. We're going to clear out anything that is there. Our list 1 will contain our x values. Our list 2, our y values. Go Stat, Calculate, number 4 for linear regression. Again, we have a negative r value due to the slope. Negative 0.66666, repeating to rounding to 7, should be known as the common fraction negative 2/3. So let's write our equation. Our linear equation for the given graph is y equals negative 2/3 x plus 1. Now we're not finished with this problem. This problem tells us to multiply the slope by negative 1. The slope of this equation is negative 2/3. So if we take that slope and multiply that by negative 1, that's going to give me a slope of 2/3. It also tells me to take the y-intercept, and it should be increased by 5 units. Our y-intercept is a positive 1. If we take that y-intercept of 1 and increase it by 5 units, we get a y-intercept of 6. Taking our new slope and our new y-intercept, we get a new equation of y equals 2/3 x plus 6. Now match your equation with the answers, and you will see that the correct answer is B. By using the graphing calculator, we took a difficult problem and made it easy. Problem number 4. Sarah has started a new exercise program that involves walking. The table below gives the relationship between the miles walked and the calories burned. If Sarah continues to walk at the rate shown in the table below, how many calories will she burn during a 10-mile walk? Record your answer on the provided grid. Be sure to use the correct place value. We're going to begin by doing a regression, and remember, we always begin by doing a linear regression. So we're going to start with our stat, edit, to input. The value for miles will be our x's. So we'll put in 0.25, enter, 6.5, enter, 8.75, enter. Arrow over. Our y values are calories burned. 27, enter, 430.5, enter, 580.75, enter. Stat, over to calculate, number 4, our linear regression. Notice that our R value is not exactly 1 because this is a line of best fit, but it is very, very close. Now, to avoid having to write down this equation, we're going to use another method to paste this equation into our y equals. Go to your y equals, clear anything out. We're going to use the variable key, or vars, which is next to your clear. Hit variables, and since we're working with statistics, go down to number 5. Enter. We want the equation that we just got, so arrow over to equation, and we want the regression equation, number 1. This pastes the equation in to your y equals. Now we're asked how many calories will she burn during a 10-mile walk. So we're going to use our table to figure that out. So let's go to second table set. Let's start at 0, go by 1, then go to second table. Arrow down till your x value is 10, arrow over. So we want to make sure we write in 660.351 on our grid. Begin by writing it in the correct place value places. Then go below each number and bubble in. Now let's look at the targeted skills. In problem number 1, we use the calculate key to find the 0, or the root on the TI-82, to find the x-intercept. In problems 2, 3, and 4, we again did regression. On number 2 and 3, we were given lines and found points on those lines. Problem number 4, we were given a table of values. To complete problem number 4, we use our vars key to paste that equation into our y equals, then used our table to make a prediction. This concludes targeting task objective number 3. The student will demonstrate an understanding of linear functions.